Let's take a look at this one. 20th. If 1 plus I over 1 minus I whole power m is equal to 1, then find the least positive integral value of m. Very interesting. Least positive integral value of m. Now, these terms are very important, these expressions, what do you call? Least positive integral value. So you're talking about integral, you're talking about positive integers. So what you're talking about is actually natural numbers. That is 1, 2, 3, 4, right? And you need the least possible value of this. Okay. So let's try to find the solutions of this first. In terms of natural numbers, in the set of natural numbers, let's try to find the solution of this equation. 1 plus I over 1 minus I whole power m is equal to 1. How do we go about solving this? We'll have to simplify this one first, right? What is this expression actually equal to? Let's try to simplify this first. What you get is something power m is actually equal to 1. But something can be simplified as 1 plus I over 1 minus I. Let's multiply with the complex conjugate of this denominator. Let's try to bring this complex number in the numerator. And what you have is 1 plus I whole square in the numerator over here. This is a minus b, a plus b, which is a square, and minus of I square. What minus of I square would actually become plus 1 over here in the denominator, right? And this power m is equal to 1. This is given as power m is equal to 1. What does this simplify into? Let's take a look at this. 1 plus I square is actually equal to a square plus b square. Now b square is I square, which will be equal to minus 1 plus 2 times I, 2 times ab. What you have in the denominator is 2. And this whole expression power m is given to be equal to 1. Okay. This is cancelled. 2i upon 2 is actually I power m is equal to 1. Okay. So that expression, that complicated expression is actually equal to simply I. That 1 plus I over 1 minus I is simply equal to I only. Yes. And I power m equal to 1 can have many solutions. Right. We remember that I is square root of minus 1. I square is equal to minus 1 and I power 4 is actually equal to 1. And on the basis of this, we can say that any multiple of 4 power, that is I power 4k is actually equal to 1, where k can be any integer, right? So any multiple of 4 is okay. Therefore, m can be equal to what? M can be equal to 4, 8, 12. Now these are positive integral solutions, mind you, positive integral solutions. We could have had other solutions as well. We could have 0, we could have had minus 4, minus 8, minus 12 as well, but these are not being asked right now. We are only asked to find a positive integral, and out of those positive integral solutions, we are supposed to find the least positive integral solution. That is, the least positive integral solution, as you can observe, is 4. Therefore, least positive integral solution m is equal to 4 is my final answer over here. Possible values of m, as you can see, can be many. Possible values of m, as you can see, can be many, right? This is background check. This is the final answer of this question over here. So simplifying this expression in the bracket was the important thing, as you can observe over here, right? Right. Yes. And that is all in this exercise. This is miscellaneous exercise of chapter 5, complex numbers and quadratic equation. That is all in this exercise.